Hi all. I guess it's a really long break since my last video. I had my exams and all, so I was a little busy with that. So yes, continuing with our series on basic operations in signals. Last time we were seeing time shifting. So obviously the next thing is time scaling. So let's not simply think what is time scaling and all. Let's suppose there is a graph like this, okay? So x of t is given like this. And if someone is coming and asking you, if x of t is like this, how will x of 5t look like? And that's their question. And how are you going to find x of 5t? So to start with, let's suppose there is, you just note down all the points, okay? So at x of minus 2, the value is 0. At x of 0, the value is 8. At x of 3, the value is 8 again. So basically from 0 to 3 everything is 8, and again at x of 5 the value becomes 0. So I'm just noting down the values, okay? Now suppose they are asking what is x of 5t. Suppose if you substitute minus 2 here, so x of 5 into minus 2, which will become x of minus 10. And what is x of minus 10 here? So it's 0 basically. So it's 0. But what do you need? Like you need this point. So where will this point lie in 5t? So basically you need to find which value, if I substitute here, will bring my minus 2. That is x of 5 into something should ultimately x of 5 into something should ultimately give me x of minus 2, right? So that is the basic idea involved here. So if you do basic algebra, you will know, so this something will be minus 2 by 5. So the idea is, last time when you substituted x of just minus 2, you got a 0. That is, this is my t initial value. Whereas now initial value of t, I just substituted minus 2 and I got my 0. But whereas now I have to substitute x of 5 into, for t I have to substitute minus 2 by 5. Last time it was just 2, but it's 2 by 5 this time. So x of minus 2 by 5, this will get cancelled. So x of minus 2 here is 0. So this time t final values is minus 2 by 5. It's not just minus 2. So what we basically did, there was something called 5 which is multiplied in front of my t here, and because of that just minus 2 became minus 2 by 5. So whatever is getting multiplied here will be is getting divided here, so that I can bring my actual point 0. So if at all I want 0, 0 is going to remain 0, because 0 by something is 0 only. So let's forget 0. So if at all I want this minus 3 case, again it is plus 3 case, again it's going to be the same. That is x of 5 into 3 by 5 will give me x of 3, which is equal to 8. So in my new graph, that is the scale version of this graph, it's going to be x of 5 into 3 by 5. So that is, suppose if this is x final, that graph I should be substituting x of 3 by 5, which will give me the value of 8. That is the t value, right? The t value is basically becoming 8. So 3 value is basically becoming 3 by 5, which is giving me 8. So what basically happens is, this divided by 5 is happening everywhere. So minus 2 became minus 2 by 5, 3 became 3 by 5, and 5 also will become 5 by 5. So if at all we plot this again in a, that is x of 5t graph, that is going to look like this only. The shape is not going to change. Shape is going to remain the same, but what is going to change here is minus 2 is going to become minus 2 by 5, and plus 3 is going to become 3 by 5, and 5 will become 1, and 0 by something is 0, so that will remain the same. and the amplitude values won't change, so that is also going to remain the same. So this is my new x of phi t, sorry, so this will be x of phi t. So this is how my x of phi t will look like. So what basically happened is this was little expanded, minus 2 to 5, whereas this got shrunk, that is minus 2 by 5 to 1. So when I multiplied by a factor of 5, the graph basically shrunk by a factor of 5. And a quick analogy question, if at all when I'm multiplying by 5 it got shrunk by 5, so when I'm dividing it by 5 it will just get expanded by 5, so this will just get expanded by 5. So x of t by 5 will just look like the same thing, only the shape is again going to remain the same. So this will be x of t by 5. The shape is going to remain the same, whereas minus 2 would become minus 10, 0, 3 would become 15, 5 would become 25. I hope you understood the analogy. And so this entire process is called time scaling. Last time we saw shifting, and this is called time scaling. Just scaling the graph in time axis, expanding it and shrinking it and all, so it's called time scaling. So if at all you would have been noticing something, all this while we were multiplying these factors and all inside the bracket, that is I multiplied 5 inside, like I multiplied 5 with t, I multiplied 1 by 5 with t. So what if I multiply it out of t, that is 5 into x of t. X of t is going to remain the same, but what if I multiply something with x of t only, and what if I divide something with x of t only? This time I'm not touching my t, I'm just multiplying and dividing to my x of t. So let's just take the same example. So x of t values is going to be this only, this values. So I'll just write it down here. So x of minus 2 will be 0, x of 0 will be 8, x of 3 would be 8 again, x of 5 would be 0 again. And what I'm doing is I'm just multiplying everything with 5. I'm just multiplying everything with 5. So if at all I'm multiplying this side with 5, by 5, I have to multiply it here also with 5. The factor has to be multiplied both sides equally. Just don't get confused with decimal. It's not decimal, just multiplication. So if at all I multiply it by 5, 0 will remain 0. Here also 0 would remain 0. Here two things will become 40. So basically what happened when I multiply it with 5, nothing happened in time axis, it's just this value got, instead of 8 it became 40. That is, nothing is going to get affected in the time axis. Minus 2, 3 and 5, this is going to remain the same, but instead of 8 here it's going to be 40, and this would be 5 into x of t. And a quick analogy question, if at all multiplying by 5 is making the value, the amplitude gets scaled by 5, what will happen if I divide this x of t by 5? As you guessed, 8 would become 8 by 5. So 8 would become 8 by 5. That's what is going to happen here. So when I divide this, when I divide by 5, x of t by 5, that is going to be like, same thing. Nothing will happen to my time axis. So this thing would be time axis and this thing. So this would be 8 by 5. So this time I didn't touch my t, I just played around outside my t, that is to my x. So that's so this process on a whole is called amplitude scaling. So what happened, we didn't touch the time axis, we just played with the amplitude axis and we just scale stuff. So this is called amplitude scaling. Now let's do some more games with the same graph, that is the same thing only. All this while I have been multiplying stuff. What if I add stuff to the x of t, or add some numbers to the x of t? That is, last time in amplitude scaling we just multiplied outside x of t. Now what if we add in outside x of t? In time shifting we were adding it inside t. Now what if we add it outside t? So that is a jugglery that we are going to do now. So x of t plus 5, let's suppose. So again it's very simple. X of minus 2 is 0, x of 0, x of 3 and x of 5. X of 0 is going to be 8, and this is going to be 0. You are basically adding 5 on both sides. So you here also you will be adding 5. So this would basically be 5, 13 and 5. So what happens when you basically try to plot x of t plus 5? Your graph wouldn't be starting at 0 this time, because x of minus 2 is 5. So if at all you have x of minus 2 and this suppose x of 3 and this is 5, x of minus 2 will be starting at 5, this will be 5, and this will travel up to 13. So this would be 13, and this would travel here. Let's suppose if we extend a 3 here, it would travel till this point, and again it would drop down to 5 only, not 0 this time. So this is how my graph would look like, something like this, the same shape. But what happened this time is it just got not scaled up, it just got pushed up. So what I basically did is, whatever is here, I just pushed it up by 5 units here, So basically when I add 5, it just got shifted up. So what will happen when I subtract 5? This will just come down by 5 units. Basic analogy only. And this thing is called amplitude shifting. In the previous video you might have been seeing time shifting, and this is called amplitude shifting. So that's it for this video. You might be thinking all these things are very simple, basic, but actually even very hard questions could be made even with these concepts. If at all you look at questions that are being asked in GATE with these basic questions, that basic operations, time scaling, shifting, and all these things, you might be breaking your head. So it's not that, yeah, it might be easy to understand, but when we implement it in really confusing problems, then it would turn out to be a headache. So what is the one key solution for the mastery of this topic is practicing in a repeated way. So that's it for the video. If at all you want to tell some suggestions or ask some doubts, or convey anything to me, you can make use of the comment section. Thank you.